Okay, great. So start again. Do my 25-minute start now? Now. Okay, awesome. Okay. So yeah, as I said, I think I've been sort of living the dream that Fred talked about. So I'm going to go from, I guess, the general stuff to the specific, right? I'm going to talk about microservices at Gilt. Okay. We learned a huge amount, and in a sense, there's a whole ton of war stories and things that I hope that you can take away from what we've learned about microservices. All right. So the analogy, I needed a sexy title for my talk. Okay. The analogy comes from the fact that effectively the microservices that run Gilt.com, there's approximately 300 of them. Okay. So that's the initial sort of analogy to the hotgates of Thermopylae. The interesting thing though is like, so what about the Persian horde, right? What is it that these 300 microservices are kind of, protecting us against or defending us against? And it turns out to understand that you need to know a little bit about Gilt's business model, right? Now it's interesting, if you're in America, everyone knows who Gilt is. It's like a household name, okay? Very much less so in Europe, all right? So to give you an idea of what it is, so effectively the business model is a flash sales model. It started in 2007. It's been pretty interesting in that, in its first year it made $1 million. 4 years later, its revenue was $400 million. When we were recently acquired, at that stage, our revenue was approximately $700 million, all right? So a pretty big organization. And what's the idea? Well, we get our hands on designer brands, luxury fashion goods, okay? Typically, we get them at discounted prices because perhaps it's last season stuff or it's overstock or whatever. But the focus is always on really high quality luxe brands, okay? We get the product in, right? And one of the big things that's really important is making the product look absolutely fabulous. So we actually shoot all the product in our own studios, all right? So we have an entire creative division. The product comes in, the merchandise comes in, and we photograph that, okay? We are a real company, so we're actually selling real stuff. We have our own warehouses, right? And we have our own kivas, and so we deliver product, okay? And ultimately, the reason why I'm telling you all this is because this is a very unique business model. There is no kind of off-the-shelf tool that you can buy to run a flash sale business, right? And effectively, all of the software that runs these parts of the business, they've all actually been written in-house by our teams, okay? So a key part of the process is that we sell every day at noon. So we tell all of our members, we say, hey guys, today we've got Louis Vuitton. It's going to be live at 12 o'clock. Come get it. First come, first serve, right? We have low quantities of highly desirable products available, and they're going on sale at noon, okay? And then this is what our customers look like, okay? Effectively, you do end up with this horde every day, right at noon. And this is, in a sense, the engineering problem that is really interesting and exciting for Gilt. And I think it was very unique for us as well from a microservices perspective, right? Because as we moved towards a microservices architecture, we didn't know, were we going to be able to handle this kind of load, right? What our customers really look like from an engineering perspective is this, right? The big spike that you see at 4 o'clock GMT, which is noon in the States, that's effectively our traffic load on one of our load balancers, okay? So handling this pulse load has been one of the unique engineering problems that we've learned to solve at Gilt, right? And we've learned, in a sense, the hard way. As our customer base and our business went viral, effectively, we had outages, right? And it's interesting. It's like, so how do you engineer? How do you build everything so that it's super scalable? We started with a world that was all Ruby, and that was good. Then we got to the point where Ruby simply couldn't handle it, and we actually had some great Ruby engineers working on the site. But the reality was it simply couldn't do it. So we adopted a technology called Java, and effectively over time we were able to use this technology to get the kind of performance that we were looking at. Okay. This is a very interesting diagram as well, just from a failure perspective, okay? As you can imagine, our revenue at a given time of the day actually tracks this line as well, okay? So failure is not linear. If we fail, at these times of the day, that's okay, right? But if we fail around this time, just for a couple of hours afternoon, that's actually, of course, really damaging. It's material to our business. Okay, so being reliable, being scalable is just massively important. Okay, so so we think about the hype cycle, adopting microservices. Okay, and this is the classic kind of founded on Google hype cycle curve. Okay, technology trigger, something happens, everybody gets excited, right? Everyone's going, oh my God, this is amazing, and then all of a sudden, after the peak, you get to this trough of disillusionment. Okay, the trough of disillusionment is where you go, oh my God, this is dreadful. It's not what we thought it was. And if you're lucky, you can get through the trough to the slope of enlightenment, and then hopefully then the plateau of productivity, right? And Gilt is now here with respect to microservices. And so this is effectively how it all panned out. 2011, right? Like, oh no, we've got a monolith, it's terrible. Oh, what do we do? Maybe these microservices can help. So we were very, very excited, right? And we're kind of like, how do we adopt this new architecture to try and actually go faster? Okay? And so 2012 is like, it's like, yay, we're doing great, this is amazing. And then 2013, we're like, we are at the top of the mountain, this is brilliant, we have 300 services, right? And the interesting point there is as well, like as part of that thing, this is a chart of the number of services over time on Gilt.com. And effectively, you do see a point of inflection around here, which is the 12th of, January 2012. It's a very interesting point. That was the point when we officially decided we were a Scala house. We had gone from Ruby to Java. We landed on Scala, and we absolutely loved it. And in a sense, that adoption of a new language, a new functional programming language, and everything that gave us, that's what kind of led to the point of inflection there. Okay, so we were at the top of the mountain. 2014, holy crap, look at all these services, right? It's a hard world to live in when you've got 300 things out there to monitor, to manage, to understand, okay? And there really was a moment where you're going like, God, this is actually hard. And there are a whole ton of problems that we didn't know we were going to have. One of the big ones, right, and it's still one that we're kind of coming close to the end of actually, is a staging environment, okay? When you have, one big service, it's easy to create staging environments or pre-prod environments. When you've got 300 of them, trying to replicate those 300 services into a staging environment is next on impossible, okay? And believe me, we've tried it. I mean, we've thrown ourselves at it. So in the end, actually, one of the interesting things there is we've learned basically to stop using staging environments and simply test in production, okay? And figure out how to do, I mean that in all seriousness, how do you test safely in production, right? And it's an incredible skill and a technique to learn, okay? So 2015, we kind of say, let's get a handle on this, right? How do we look at what we've created, continue to innovate at the pace that we've liked? And now this is effectively where we are now. But I think probably by January or February was this weird sensation of, wow, we actually know how to do our job, right? Which is kind of great. And then it all changes. Okay, so what do I want to talk about? Lessons from the slope. That's the slope on the way to the plateau. First thing is that microservices is very much an emergent architecture. Okay, Fred alluded to developer anarchy. Effectively, when we went with microservices, we completely decentralized all of our decision making. And you're probably used to, in many organizations, the idea you've got like a brainiac chief architect who tells everybody what to do and everybody bows and goes and does it, right? We don't have that, okay? We've completely moved all of the decision making on architecture and on technology choice to the engineers and to the teams themselves, okay? Now, when you do that, then you end up with a big pool of stuff. So then you have to figure out, how do I take that pool of stuff and understand it, okay? How do I think about it, okay? So I'll talk about that. I'm going to talk about how to manage ownership and risk. Managing ownership, it was a critical problem. And interestingly, this was a bottom-up problem. Our engineers were unhappy that they didn't know who owned what, who is responsible for this service. I may have written or committed to it one day, but it doesn't mean I should be the guy on call. How do we figure out the ownership piece? A very important technical note about making your clients thin, and then I'll talk a little bit about then avoiding snowflakes. Okay, emergent architecture, okay? It is incredibly hard to think of architecture as just a line, right? And literally, we became aware that effectively we had approximately 265 services. Here's our architecture. Bang, that's a list, right? How do you reason about that? I mean, it's just like I don't even know where to start. Like the average human mind can hold 7 plus or minus 2 things in its head at any moment, right? And here we are with close to 300. Just impossible to reason about it. So we looked and we said, so how do we? I was actually very fortunate here. I had actually gone to Tokyo for 2 years, and I came back and I was faced with this problem. How do I understand these services, right? We use a technology called a spreadsheet, all right? Now, it's actually very interesting because we thought, right, that, like we have 265 services and somebody said, I know, let's build a service to track our services, right? And at that point, we knew there was something not quite right. So instead, it turns out, spreadsheets are great. They have collaboration built in. They're, Turing complete. I mean, you can practically do anything you want with it. So we actually took the brave move of simply saying, let's build a list. What are the services that we have and kind of who owns them, right? And this was actually the first step towards going, okay, actually, we're getting a sort of a handle on this. We then looked and said, it's interesting, why don't we add a little bit of classification to this so that we can understand more about our systems? We just said, let's play with a 3-level taxonomy, right? Main functional area of the business that this service is relating to, the system that it's involved in, and then a subsystem. Okay, and then it turns out that by just kind of going through the list and saying where do these things belong, we actually inferred an emergent architecture. Okay, and that was actually a really, really nice thing. Okay, some things that we learned. Some services are incredibly simple. Okay, and other services are actually deceptive in that they you think they're simple, but actually they're not. Okay, so what is the evidence to support that the services are simple? This is a logarithmic graph here of the size of our services, okay, the number of lines of code. And it turns out most of our repos have approximately 2,048 lines of code, right? Now that's all the code. That's the build code, the Java code, the model code, or the Scala code, whatever, right? So it's not as small as some organizations, but it's actually reasonably good, okay? So this is great. You can drop into a repo and you very quickly understand what the hell the service is doing. That's really nice. As well, in terms of the number of files in any repo for any service, I mean, we've got typically less than 32 files, okay? And again, that's everything, right? So again, that's actually pretty good, okay? Our services are generally quite small. There are some exceptions. What became really interesting, though, in terms of the taxonomy approach was this. When we did effectively a pivot table, would you believe it, we realized, hey, there's only one service here that does authentication on the back office systems. This is the overall back office architecture here. That's kind of nice. That's one for billing. That's great. And you look through, and when the counts get high, 9, or down here, order processing 8, right? This is where you realize that actually these services are kind of deceptive because in their own you can't understand them, right? They're part in any particular service in the order processing suite or cluster. It only makes sense when considered in tandem with the other services that it works with, right? Effectively, when you do microservices, you kind of explode out the complexity, right? You don't get rid of it. You just move it around a little bit, right? What you've got to hope is that you've moved that complexity into a constellation of services that makes it easier to understand. But one of our things was, okay, we need to make sure then that we have the right people, and in a sense, we do need to do a little bit of architectural thinking and documentation around some of these areas, because otherwise, going into one repository, you're not going to get the whole picture. So that was interesting. A very, very simple approach. Apply a taxonomy, see what happens, right? And then effectively, we're going to get some kind of emergent architecture, okay? So one of our things as well, so we talk about architecture and exploding the way we architect. We've come on this organizational unit called the department, which actually has solved an enormous amount of our problems. Fred talked about organizations and how you structure yourselves, I think, is as critical for your success as the technology choices. what we've learned to do is stop making decisions, at this grand level, push it down, right? But don't go down to like 100 engineers. If you push the decision making to each engineer, then what you're going to end up with 100 different solutions, right? So how do you get the right level of consensus, right? We get that at the department. So let me talk about ownership, and then I'll round out on my ideas for the department. So what we said is, based on this list, this genome, we said, okay, who owns the software, right? We create these departments. Departments are approximately 16 to 20 people in size, and all engineers, okay? There's a director. The director is on the line. He owns his estate. Maybe he's got 50 or 60 services, right? It's up to him or her to make sure that this is the way they want it to be. So they have full accountability for what they have. And then the director is kind of assigned the services, the landscape to the various teams, right? So Team Ouroboros, you own these 12 things, right? You must make these great, okay? So we've kind of distributed the problem there. So one of the other things then is that teams, the software teams themselves, they're responsible for building and running their services, right? Effectively, what we've done at Gilt is we've built in pure DevOps, we've moved everything to the cloud, and ultimately the teams build and run their software. This is different from Google's SRE model, where one team is a product team that builds something and they hand it over to a different team to run it, okay? We've landed on, it's really important for the teams to run and own their own stuff in production. So we basically end up with a Iraqi style kind of structure here that turns out to be incredibly powerful, right? Teams are responsible for building and running their services. They get given KPIs, solve this problem. We want to increase the number of clicks on this page, right? They go like crazy at it, and effectively they're responsible for owning and running the services they use to solve the problem. Directors are accountable. This is kind of a level of leadership over a team of teams, okay? And what we found, which was really great, was we built an entirely powerless entity called the ARC board, right? High influence but zero power, made up of people from all the departments and our most senior engineers to try and figure out what kind of consensus we need at the high level, right? It's really great. The architecture board makes amazing recommendations, but you can completely ignore them, okay? You can do whatever you like, okay? The key thing is that if you do choose to ignore the architecture board, you're on your own, right? And that's the price of doing that, okay? And what we've actually found is having this virtual architecture board has really worked for us, right? I mean, it's one of my favorite kind of meetings of the week is the architecture board. Just the conversations are incredible. So, and how do you create an architecture board? So effectively, we open sourced our constitution. And what's actually really nice then, when you want to change the constitution or the makeup of the ARC board, you submit a pull request. It's great. Likewise, what these guys come up with, their standards and recommendations, right? And as we discuss what these standards or recommendations are, we use actually a ThoughtWorks style tech radar. Effectively, again, these are all tracked on a GitHub repository. These two are both public, so you're more than welcome to take a look at those, okay? Okay. Interesting numbers, 5 plus or minus 2, perfect size for a team. We do not need engineering teams larger than this, okay? I think that's kind of a really important learning that we have found. And interestingly as well, like when you've got a team like this, we do have team leads. Team leads code about 85-90% of their time, right? They are not a manager. We just don't have management positions, okay? 20 plus or minus 4. This is actually something similar to the size or the optimum size for a classroom, apparently. Okay, this is the perfect size for a department. You can get these people into a room, right, and you can say, guys, here's what we need to do. And actually, within a department, you can have mobility between teams, and people feel good about it. They don't feel too shuffled, right? So this actually works out really, really well for us. Okay, 30%. This is the amount of time that we try and get for the split between your operations work as a team, because we've kind of embedded ownership and ownership of production into the teams. And so what we've landed on is about 30% of the time is spent on kind of routine maintenance and operational stuff. Okay, we try and get to a point where like 70%, sometimes 60%, it'll change per team. Is actually spent on new interesting stuff. Okay, this has been also then one of the other very, very interesting things that we've done is we said all these services, right? And then you've got all these engineers over here, right? There are less engineers than services, and many of the people who've written the services have moved on to new jobs, okay? So how do you handle the risk? So what we did was we took every service and we classified each service by simply saying, is it active? Green is this service is under active development. We absolutely love it, okay? Passive is we're not really developing on this, but it looks pretty good, all right? And we're okay with it. We feel good about it. And then red is at risk. At risk basically means somebody told me to own this service, right? I'll get it up and running for you, but realistically, I'm not offering any guarantees or any SLAs, okay? And so we formed these donuts to track our ownership, and it turned out we hit, this is really brilliant over time, July. You see a black line there unclassified. You get an idea, a quarter of the code base is under active development. 43.9 is under passive. And this was like a real red alert for us. Holy crap, there's almost a third of our stack that we don't feel good about. That's a real eye-opener. So we set out then to weave in our ownership needs, right, and de-risking this matrix here with our tech strategy. September, we've gotten rid of the black ones. We have a better idea. October 2015, we've moved our unknowns to 24.0%. And this is just amazing. February of this year, we got down to 18.4, right? This is a great way of tracking and understanding the level of risk you have. And it's actually interesting, when you do microservices, you can build something like this. When you just got a monolith, right, it's just one thing that's either kind of red or green or orange. Okay. So it turns out anyway that we thought about the architectural areas. These are the main areas of Gilt tech. We built departments around these areas, around ownership. We have lots of flexibility within the departments in terms of team structure. Somebody in a meeting once said, you've just pulled an inverse Conway maneuver, right? And it turns out I think we have, right? Effectively, we've modeled the organization after the architecture that we wanted to achieve, okay? And that actually felt really, really good. Okay, so a couple of quick notes before I get kicked off. Thin clients, okay? One of the things that we did, which was wrong, when we wrote a service, every engineer would write the client code and make a jar that people could use to consume the service, okay? And into that client code, they'd put all sorts of ditties and all sorts of stuff, right? Consumers would use the client jar and then away they go, okay? This is hell. The reason why is because the client code implicitly pulls in the service dependencies of the repo. The consumer has their own consumer dependencies, and that's when you get clashes in terms of dependency management and versions, right? Now, like, this sounds like a small, isolated, just suck it up and deal with it. When you've got 300 services that you've got to upgrade to a new version of a jar, right? And you have to stop your entire tech team for 2 months to try and figure out how we're going to get this massive upgrade done. That's just not great, okay? This was a mistake, okay? What you really need to do is something like this. We've adopted API doc, which is really good. You define your service in a technology agnostic language, and then you basically generate client code. The trick is that when you generate code, this code should have no dependencies whatsoever, okay? And effectively, by doing this, by having these client code be zero dependency, it's absolutely decoupled everything for us in terms of that kind of risk. So I would say keep your clients absolutely as thin as possible when you do this. Okay, so last point, I'll be really quick here, is on the building of snowflakes. Effectively, I did a meetup at the Dublin AWS meetup, and it turns out that we have, I think, 7 different ways to deploy code to production, okay? And that's just crazy. Right, you know, the complexity of managing 7 different pipelines, okay? Effectively, what we had done was every team reinvented their own solution for how to deploy their services to Amazon. And some of these solutions actually involved quite a lot of code to actually figure out the deployment pipeline, okay? So you have to ask yourself, really, you know, did this code help us sell more dresses, right? Should we have been doing this, right? So Andre's rule of 6 now applies, right? Effectively, if you wait long enough, typically 6 months, Amazon will have implemented the solution that you're looking for, right? So you're actually better to put up with it, right? And then effectively, 6 months later, you'll have a solution, right? And it turns out now, actually, in terms of deployment, we discovered, hey, this is actually really interesting. We are now basically using as much of the Amazon tooling as possible, okay? And we need the lightest kind of layer over this in terms of Python to kind of, a small Python framework to layer it all together. We call that Nova, and that's also just recently been open sourced here. So if anyone's interested in that, if you're in an AWS world, I think you should have a look at that. It uses all the goodness you'd expect, Docker and all the great stuff. And what it actually supports in terms of rollouts is amazing. And it's things like having dark canaries and canary releases. That's what lets us test in production. Okay, this stuff is really, really great, right? Okay, so thank you so much.